Now we're going to look at solving quadratics with complex numbers. So that means that we have a quadratic with a complex root or solution. Okay? Before we called it no real solution, now we're going to look at how to actually simplify with it. We are going to do 3 examples. Okay? One with the quadratic formula where there's no simplifying. One with the quadratic formula where we can simplify the square root. And then one where you don't even have to use the quadratic formula. So when you're doing this, you're first going to use a quadratic formula like regular, plug in your a, b, and c, simplify down. But when you get to your discriminant, if it's negative, you're going to actually simplify it with your imaginary radicals, okay? And then we're going to learn how to split it apart to be able to write it in a plus bi form. If we have a complex number, we always want to write it in this form. All right, so first we always check to make sure we're equal to 0. So in example 1, x squared minus 3x plus 10 equals 0. We are ready to find a, b, and c. So my a here is 1, my b is negative 3, and my c is 10. Okay, I'm going to plug that into my formula. X equals negative, plug in my b, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Okay, we're going to start simplifying now. So remember, we have 3 areas that we can simplify before we're able to write our final answer. We have this in front. You always check for those double negatives. So a negative times a negative 3 is just a positive 3. There we go. And then we need to evaluate our discriminant. So what does negative 3 squared minus 4 times 1 times negative 3 equal? Okay, you should have gotten negative 31 as your discriminant. And then 2 times 1 is the third spot we need to simplify, and that would be 2. Okay, so we have drastically simplified our solution, but now we want to try to write it in the form a plus bi. Right? First, we have an imaginary radical here that we need to simplify. So the square root of negative 31, remember, that's like writing the square root of negative 1 times the square root of 31. Okay? Square root of negative 1 is I. Square root of 31 can't simplify. All right? We can't break it down, and it's not a perfect square. So we're going to leave the square root of 31 so we can have an exact value. We're trying not to round here. Okay, so I'm going to take that, and I'm going to replace it back in my problem. 3 plus or minus I square root of 31 over 2. Okay, so we have I, but we're not quite in a plus bi form. We actually want to split apart our denominator. Okay, and this is going to be the last step here. We can do 3 over 2, and then you can leave the plus or minus. We're going to leave both answers together. Okay, you could separate them, one with plus, one with minus, but it's also okay to leave them as one unit. And then we want to do square root of 31 over 2. That's our b. So here's our a. Now we need our b. And then our I. Okay? So now we're in a plus bi form, and we are done. All right, let's try it again. Let's see what happens when we can simplify the square root. So I'm equal to 0, so I'm going to find a, b, and c. What are a, b, and c equal to? A is 1, b is 4, and c is 5. Okay, I'm going to go through my formula. Okay, and you could try to factor this, so I didn't talk about that. When you look at these, you don't necessarily know that it's going to be an imaginary solution. You just see, oh, I have a quadratic I need to solve. If I try to factor this, there's nothing that will multiply to positive 5 and add to positive 4. So I would know that I would have to use quadratic formula. And then through the process of quadratic formula is when we figure out whether or not we have an imaginary solution. So let's plug that in. Negative, plug in my b, plus or minus the square root of b squared minus 4 times a times c, so b, a, c, all divided by 2 times my a. Okay? And what is your discriminant equal to here? All right, let's check. Negative 4, there's only a single negative here, so that negative will stay. Here we had a double negative, so it canceled. Plus or minus, and your discriminant should have been negative 4 over 2 times 1, which is 2. All right, let's look at our radical. We got a negative discriminant, which tells us no real solutions. That means we have an imaginary or a complex solution. All right, the square root of negative 4 can be rewritten as square root of negative 1 times the square root of 4. That negative 1 under the square root tells me I have an I, so that's I. Square root of 4 is 2. So we're equal to 2i here. I want to point out here, when it's a whole number, right, when it's just a regular whole number, our I comes second. Our 2 is like a coefficient. When we have a radical, our I comes first so that we know that the I is not under the radical. That's just good practice, good writing skills. Okay, I'm going to replace my 2i. Negative 4 plus or minus 2i over 2. Okay, we are simplified with our radical, but we are not in a plus bi form yet. So let's take that step of splitting it apart so we have our a and our bi. So negative 4 over 2 plus or minus 2i over 2. Okay? Notice here we can actually simplify these fractions. Over here our fractions couldn't simplify, but here they can. Always simplify if you're able to. So negative 4 over 2 is negative 2. 2 over 2 is 1. And we do not have to write the 1. So we've got negative 2 plus or minus I. So this is an a plus bi form. And we are finished. All right, the last example that I want to show you is one that actually doesn't need the quadratic formula. Notice here, I only have an x squared term. I don't have x squared and x, so I can try to isolate that x. All right, so I'm going to subtract that 30 over and see what I've got. So if I do minus 30, now I've got x squared equals negative 36, okay? So if I want to solve an x squared, I need to do the opposite of squaring. What is the opposite of squaring? Taking a square root. So I'm going to take the square root of both sides. Okay? So a square root and a square cancel, I'm left with just x. So x equals square root of negative 36. Okay. What is the square root of negative 36? Good, if you split it apart, you get square root of negative 1 times the square root of 36. Square root of negative 1 is I. Square root of 36 is 6. So we get 6i. Now, this is actually missing something. All of these others, we had a plus and a minus, a plus and a minus. You will never have just one complex solution. It always has a partner. It always has a positive and a negative. So we need to include that here. When you solve with this method, all you have to do to include that is say, oh, it's plus or minus. It's plus or minus 6i. That means it could be positive 6i or it could be negative 6i. And then you have your final solution.